Hello dear students, this is Ashwini S, Assistant Professor of Mathematics. Today let us study about 3rd semester B.Sc paper 1, Unit 3, Real Analysis 2. Under this the topic which I am going to discuss is maxima, minima and extreme values of two variables. We all know about maxima, minima of one variables which has already been studied in the previous classes. Now let's see the definition. Okay. The first definition which we are going to study today is known as maximum value. So since it is with respect to two variables, the two variables which we would be considering are x and y. So let's learn the definition now. A function f of x comma y is said to have a maximum value at a point a comma b if the condition given here is f of a comma b is greater than f of a plus h comma b plus k for the neighborhood point of a plus h comma b plus k of a comma b. That is, the other way of writing the formula would be f of a comma b minus f of a plus h comma b plus k is greater than 0. This was the definition of maximum value. Let's see the definition of minimum value now. Again here we will be considering two variables and 2 points. The variables are x comma y and the points are a comma b. Now let's learn the definition. A function f of x comma y is said to have a minimum value at a point a comma b if f of a comma b is less than f of a plus h comma b plus k for the neighborhood point of a plus h comma b plus k of the point a comma b. So in other words, this is said as f of a comma b minus f of a plus h comma b plus k is less than 0. The next definition would be what is an extreme value. A function f of a comma b is said to be extreme value of f of x comma y if it is either maximum or minimum. So the simpler way of saying an extremum value is either a function should be maximum or it has to be minimum. So this extreme value is also known as stationary point. It is also called as critical point. So the names extreme value, stationary point, critical point means one and the same. Now let's see the necessary condition for extreme values. So the statement is if f of a comma b is an extreme value of f of x comma y, then the condition that needs to be satisfied are fx of a comma b is equal to 0 and fy of a comma b is equal to 0. When I say fx of a comma b is equal to 0, this is nothing but partial differentiation of f with respect to x. And when we say fy of a comma b is equal to 0, this is nothing but partial differentiation of f with respect to y, which means to say dou f by dou x should be equal to 0 and dou f by dou y should be equal to 0. Now let's see the sufficient condition for extreme value. So here we would be considering the double derivatives, which is second partial derivatives. So there are certain denotions which we are supposed to remember. So the denotions which we are going to see is if f double x of a comma b is equal to r, f xy of a comma b is equal to x and f double y of a comma b is equal to t. That is, when I say f double x, it is nothing but dou square f by dou x square, which we will be denoting it by r. And the next one is fxy, which is dou square f by dou x dou y. This is nothing but partial differentiation of y with respect to x. This is denoted by s. And f double y of a comma b, that is dou square f by dou y square, which is denoted as t. Then there are 4 conditions to be noticed here. The first one is f of a comma b has a maximum value if rt minus s square is greater than 0 and r is less than 0. Second condition, f of a comma b has a minimum value if rt minus s square is greater than 0 and r is less than 0. Greater than 0. So the first two conditions over here is rt minus s square has to be greater than 0. Along with that, if r is less than 0, we say it is maximum. along with rt minus s square greater than 0. If r is also greater than 0, we say it has a minimum value. Let's see the working rule to find the extreme values of the function f of x comma y. So there are some 5 to 6 steps which we are needed to concentrate. Now let's see step by step. So as soon as a problem is given, it is taken as f of x comma y. The first step would be to find fx and fy, that is dou f by dou x and dou f by dou y. The second step would be equating fx and fy to 0, that is dou f by dou x should be equated to 0. Dou f by dou y should also be equated to 0. When we solve these two equations, we will be getting the stationary points. Let's call that stationary point as x1 comma y1. Then the third step would be, after the second step, we have to find the second derivative, right? So I have to find fxx, fxy, fyy, which is dou square f by dou x square, dou square f by dou x dou y, dou square f by dou y dou square. We denote fxx as r at the point x1 comma y1. We denote fxy as s at the point x1 comma y1 and fyy as t at the point x1 comma y1. So let's see the fifth step. In the fifth step, we would be checking for different conditions. The first one is if rt minus s square is greater than 0 for a particular point x1 comma y1 and r is also less than 0, then f of x comma y has a maximum value at a particular point x1 comma y1. The second condition would be if rt minus s square is greater than 0 as well as r is also greater than 0 for that particular point x1 comma y1, then the function f of x comma y has minimum value at x1 comma y1. Now we have seen the conditions for greater than 0. Now let's see the next condition. If rt minus s square is less than 0 for a particular point x1 comma y1, then the function is neither maximum nor minimum at the point x1 comma y1. Such a point is called saddle point.